your time with the best efforts, go for Unacademy Plus or Iconic subscription. चलिए start करेंगे now. If you are ready to learn what is the linked list, how it is a linear data structure, how it is organized, how it is accessed, and multiple small things, what you need to do is you will have to ready for learning. So if you are ready, type down in the comment box. जल्दी से comment में लिख दीजिए are you ready or not, and we will start. Good evening everybody. जितने लोग यहाँ पे हैं सबको good evening, and if you are a regular learner here, please like the session. यार सेशन को like कर दो and जल्दी से type करो you are ready, and then we will start. So linked list is a linear data structure. सबको पता है. How the linear data structure linked list manages its linear order. The linear order is maintained using pointer. But now I'll ask a question. What was the problem with array so that you have moved to linked list? Problem क्या थी array में कि आप linked list पे गए? Why you have gone for linked list? What was the problem with the array? So let's first understand what are the advantages and disadvantages of array, and after that we will go for the linked list study. So these are the advantages of the array. First of all, elements can be accessed randomly. This is the one of the biggest advantage of array we have. Biggest advantage. Second thing, using arrays, other data structures like linked list, stack, queue, tree, graph, anything can be implemented. Other than that, two-dimensional arrays are used to represent matrices. So if you want to represent matrices in the programming languages, in the data structure, you can use 2D array and you can easily implement, and you can perform multiple different operations on the matrices using 2D arrays. These are the advantages. Now let's talk about disadvantages. This is important. Why? Just because we had disadvantages, that is why we had gone for linked list. So first disadvantage is number of elements to be stored in array should be known in advance. पहले से पता होना चाहिए कितने एलिमेंट होंगे एरे में. We need to know before priorly that how many elements you should have in the array. That's why because of the static allocation, you will have to allocate the memory. You will have to allocate the memory at the static time. Sometimes it might possible that you have allocated more memory but you are not using it. You may have wastage of memory. Look at this, right? Static structure, yes, that is why you will have to have declaration of the array at the static time before using it. Sometimes the problem is if you use more elements than the statically declared array, in that case the modification, the scaling of the number of elements in the array cannot be done on runtime. Problem हो सकता है. Other than that, insertion and deletions are also quite difficult. All these problems will be discussed, will be solved, will be overcome by the linked list. तो ये सारी की सारी problems जो हैं वो linked list के through solve होती है. So let's discuss about the solutions. Means if you have difficulty in insertion and deletion, yes, linked list solve this problem. If you have static structure of array, linked list solve this problem. Linked list has dynamic allocation. So all these problems can be solved in the linked list. Now we will see one by one how these problems are solved. So linked list, as we have seen, linear data structure, linear order maintained using pointers, fine. The list contains nodes. This particular linked list is made up of nodes and each node contains two fields. One is the element, second is the link. Link means address of the next node. Why? Just because we don't store the elements of the linked list on the consecutive locations. So if first element you have accessed, from first to second if you want to go, then for getting the second element we keep the link to the second node, so that we can reach to the second element wherever it is present or wherever it is actually stored in the memory. कहीं भी store करो, access कर लेंगे link के through. Now let's see. If two fields we have, these two fields we can access like this way. The first one is this particular node we will represent like that way, node. In the node we will be having, first thing is the data item, the element, and the second one is the link to the or address for the next node. Like this way we will represent the node. Then we will be having one special pointer, that is a list pointer. This particular list pointer is the pointer which holds the address of first node. So this list pointer points to the first node's link pointer points to the second node's link pointer points to the next node, and so on. And if you want to understand or visualize this linked list, the linked list looks like this. Visualize करें, there is a list pointer. Yes, the list pointer name can be different. This list pointer gives us the address of first node. On the first node we will be having address of the second node and the data item. So let's say data item is a character A and the address of second node. Then on the second node we will be having some data item, let's say it is B, and address of the next node. Similarly, here on the third node we will be having some data item, let's say it is C, and next. Here we will be having some data item, let's say it is D, and next. But if there is no any next, क्या रखेंगे, क्या करेंगे हवन? No, we will keep here null. So this null pointer actually represents that there is no any further node. सर ये प्लेलिस्ट कंप्लीट कोर्स होगा? यस खुश, डेफिनेटली ये पूरा कंप्लीट कोर्स होगा. शरद कुमार, whatever the algorithms required for gate perspective, we will discuss those algorithms. Whatever the theoretical part or the questions we will require for gate coverage, we will do it here. चलिए स्टार्ट करते हैं. Let's go for this one. So linked list looks like this. There is a list pointer points to the first node. First node contains data and a pointer to the next node. All the nodes will contain the same thing, data and pointer to the next node. Last node contains data item but pointer to the next node is nothing. Why? Just because there is no any next node to the last node. That is why we keep null in the last node. Now last particular node, this one showing, when we show null, there are multiple ways to show null. There are multiple ways to show null. Null can be represented like this or like this, a big cross, or null can be represented like this, a single cross like that way, or sometimes null can be represented like this way, grounded. All these are the representations of null pointer. I will be using this one for my entire course. You can see multiple places different representation, सबका meaning एक, the null pointer. Okay, now let's go for the next one. Next one is this null pointer dereferencing. ओहो ये कहां से आ गया यार, null pointer dereferencing. null pointer dereferencing तो बाद में आएगा, पहले लिंक लिस्ट को एक्सेस करने का देखना पड़ेगा. How access of the link happens? Let's say this is my link list. This is my link list. I want to access this data part. How can I access this data part? If I want to access any part of a node, suppose this is the node I want to access, and this particular node's data or link part I want to access, any part I want to access, I will first have to reach to that node with some pointer. मुझे उस नोड तक पहुंचना पड़ेगा with some pointer. Right now I know the address of this node. Yes, where? In the list pointer. So I can reach this node. Yes, using this list pointer. Yes, what I will write is, to access the data part, I will write like this: list arrow name of the part data. Similarly, if I want to access this one, I will access it like that way: list arrow link part. Now the thing is, the name of the parts, this one and this one, can be different based on the implementation. What is the implementation? How this node structure is implemented? Okay, let's see. Node structure. कैसे node structure define होगा? The node structure is defined like this way. If you are creating a node, you will have to create a structure in C language for that particular node. Struct node. in this particular node we have two members. What are the two members? Let's say the data part of character type. So the first part is character type of data. Now the thing is, name of this part can be different for different implementation. If any question on linked list comes, this kind of node structure they will always provide to you, so that you can understand what is the name of the part. Next, character type data. Name of this particular part can be character type of element, character type of item, character space, value, key, multiple other names you can use here, right? And the second thing is a pointer. But what type of pointer? What kind of pointer this is? This is storing the address of the node. So pointer type is same this struct node. That's why I am writing the type of pointer as struct node, and the name of pointer you can provide based on your own understanding. Star, you can provide the name as link. Other names can be next, forward, anything. Multiple names are possible. Multiple names are possible. Fine. This is the structure of a node. Understood? I guess understood. Yes or no? Let's go back previously here. So suppose in this particular linked list, if I am trying to print like this way, print F %C in the double quote comma list का data. If I will try to print this, what it will print for us? क्या print करेगा ये? List, this particular node I have reached its data part. Data part is character A. So character A I can print. If suppose I am writing a statement like this way, print F %C list का link का data. Now what it will print? अब क्या print करेगा? See, first of all, list pointing to this node. Its link part, link means I can reach to the second node. Second node का data part, it will print for me B. बहुत बढ़िया, बहुत शानदार. अगर समझ में आ रहा है तो बहुत अच्छी बात है. If you are understanding it, that's amazing. Understanding this one? Can you please confirm till now? Understanding or not? Yes or no? Okay, now let's go and let's try to understand few more things. What are those things? Suppose if the list is empty. Suppose this is a list. You can see a list. There is a list pointer. I have named it as a start. Start is pointing to a node which is having integer value 6. सर इंटीजर कैसे? अभी तो आपने कैरेक्टर बताया. अरे if I want to store characters in the linked list like this way, I can have character type of data. If I want to have integer linked list, I can have integer type of data. So if suppose I am having a list like this way, suppose I want to check if list is empty or not, means there is no any element in the list. If there is no any element in the list, how can we check it? How can we check it? Though condition. So condition for list empty is if my list pointer start is not pointing to any node, but it is pointing to null. So if my list pointer, whichever the list pointer name given, if that list pointer is equal to null, then list is empty. This particular condition you can write in this way also if not of start is true. Start is null, null means false, not of false is true. So if this condition is true, when this condition can be true when the start is null, means empty list, means the list is empty. खाली है भैया, कुछ है ही नहीं। समझत नाही के समझत हो। समझ में आया कि नहीं समझ में आया? अरे छोना बाबू बोल दो, छोना बाबू समझ में आ गया कि नहीं आया? अरे समझे का ना ही समझे। So if start is equal to null or not of start is true, you can write any of these conditions to check out if the list is empty or not. If I am checking list is not empty, then do something. Not empty list. If I am checking list is not empty, what will be the condition for that? Condition for that is just opposite of this. If we have start which is not equal to null, or I should say if start is true. Start is true means start is pointing to some non-null value, means yes, we have at least single node. That is why non-empty list. Now if I'll ask you one question, that I will wait for your answer. I will wait for your answer for this particular question. How can you check that you have only single element in the list? How can you check that you have only single element in the list? What will be the condition for that? Single element present in the list, what will be the condition? What will be the condition? I am waiting for your answer. I am waiting for your answer. I am waiting for your answer. जल्दी बताने का. Single element. What should be the condition? The condition should be if start is pointing to first node, yes, but its link part is null. Here null is present. Then only single node you will be having. Only single node you will be having. Yes. So what I will be writing, if the list pointer start का link is equal to null. Great, good. अरे क्या बात है. List pointer link is equal to null means single node you have. In other way, how can I write it? In other way, I can write it like this way, or if not of start ka link. Is that fine? In this case, this condition is true when you have start ka link null, means single node. Good, good, good. Priya, Ankita, nice, 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 great. Very, very good evening, everybody. Whoever have joined now, very good evening and very, very welcome. Understood what is the empty condition or empty list? Understood how to access the node and how to access this particular linked list, how to access linked list like this way. Okay, now we are going to talk about one runtime error. Yes, this is a runtime error, null pointer dereferencing. What that null pointer dereferencing error is. Suppose this is the list. This is the list and there is a pointer P pointing to this node. There is a pointer P pointing to this node. Fine. If I want to access like this way, printf %d, just because integer list it is, p arrow link arrow data. If such kind of statement I will be having, look at this, p pointer pointing to this node, yes, its link null, p का link क्या मिलेगा? null. So what exactly ultimately you are trying to access is null arrow data. कहीं भी at any place, if you have null arrow something, that is an error. Null pointer represents that there is nothing. Null pointer represents there is nothing, but with that, how can you access any data part or link part or something? Anywhere? No, this particular thing, this particular statement will throw you an error which is called as null pointer dereferencing error. Null pointer dereferencing. So when null pointer dereferencing you can have when the condition comes like this way. Some pointer you will reach to null, arrow something if you are having whether data, link, whatever. कहीं भी अगर null arrow कुछ आता है means you are having null pointer dereferencing. Is it okay for you? This is very important point, just because last year there was a question based on this concept and students were easily able to solve this particular question when they knew what exactly this null pointer dereferencing is. So with the null pointer, if you are trying to access something, that is null pointer dereferencing. So null arrow data, null arrow link, anywhere if you will be having such condition, that particular condition will lead us to have this null pointer dereferencing. बहुत ही easy concept है बबुआ, बहुत easy, बहुत easy. चलिए आगे बढ़ते हैं, अब बात करते हैं लिंक असाइनमेंट की. बिफोर वी अंडरस्टैंड द लिंक असाइनमेंट एंड मल्टीपल थिंग्स, I will ask you a simple question in the C language so that you can understand simply. So that you can understand simply like this way. Look at this, look at this. Suppose you have created two variables, integer variables. There is no any picture of linked list right now. I am showing you. I am just showing you a simple C language assignment. This kind of statement you had. What does it mean? The meaning of this is, in the main memory you will be having some space for two variables A and B. The value of variable A is 5, the value of variable B is 10, right? So in the memory we will be having space for variable A. Variable A value is 5, variable B value is 10. If I write B is equal to A, what does it mean? What does it mean? What does it mean? What does it mean? What is the meaning of B equals to A? You will say value of A assigned to B, value of A assigned to B, value of A 5 assigned to B. Like this way? Like this way? Like this way? No. No. Why? The thing is, I will have to go to the location of B. Location of B, whatever the value present on the location of B, that I will have to update. That I will have to update by what? Value of A. Value of A is 5. So exactly when you do the assignment, in that particular assignment, what you should do is, from the right side you take the value, in the left side you go to a location where you will have to assign the value. तो असाइनमेंट में राइट साइड RHS will give you, right hand side will give you the value which you will have to assign. Left hand side LHS will give you the location where you will have to assign the value. If you are fine with this small concept, I would like to extend the same kind of concept over this linked list and you will be amazed to see this change. बहुत आसानी से आपको ये समझ में आएगा. Now look at this. If I am saying this, can you tell me what does it mean? From right side I am giving you a constant value 5. Yes. In the left side I have given the location where to copy value 5, where the data part of start node. Start is pointing to this node. Yes, it's data part. This location updated by value 5. Is that clear or not? Is it clear or not? Can you please confirm this is clear or not? क्या इतना easily समझ में आया या नहीं आया? If you understood this, I am going to write another statement. What does it mean? I have taken a pointer, let's say pointer P is node type of pointer. That pointer P is equal to start ka link. Start ka link. What is there in the right side? Start this node, link part, this value. This value. What is the value in the link part of start? Link part of this node is actually containing address of the second node. What it is containing? Address of the second node, this node's address. So this node's address I will have to assign into pointer P. Pointer P will be having address of this node. Means pointer P points to the second node. Clear? Now, if I want to write like this, what does it mean? From the right side, you take the value. What value? P, link or data. P pointer pointing to this node, link and its data 9. So from right side, take the value 9 and assign it towards left side, where in the data part of P. Data part of P means this particular part of P. P pointer pointing to this node, its data part will be having now value 9. Is that clear? क्या आपको ये सब कुछ समझ में आ रहा है जो मैं एक्सप्लेन कर रहा हूं? Are you guys understanding whatever I am explaining here? Why? Just because these are very important small concepts which will be required for your learning. If you understand these small things, the linked list becomes easily. Linked list आपके पैरों में होगा. Got it? चलो और small changes देखेंगे. Let's see few more things before we move to the actual questions. Look at this. Okay, let me make it like that. वे थोड़ा easy बना देते हैं. थोड़ा easy. Wait. Let me make it more easier. Right side P link. Right side P link. Right side P link. Right side P holding the address of this node. Yes, I have reached to this node. Its link part. What its link part is holding? That value. The link part of P holding the address of this node. Next node. Yes, so address of this node I will have to copy somewhere, where I will check out start ka link part. The location is link part of start. This particular start, its link part I'll have to update. The location I have reached to link part I'll have to update by address of this particular node. I did it. Understood? So P pointer pointing to this particular node. Yes, it's arrow link means address of second node. This particular address of second node I'll have to copy in the link part of start. So in the left side you will have to check out which location I'll have to copy the address of this node. Location is link part of start. I have gone there, I have changed it. I guess now you guys are understanding what exactly the meaning of this assignment. So if you guys are clear up to this point, let's go and let's try to solve this question. This particular single question I will solve with two ways. दो तरीके से मैं question solve करूंगा. One is the regular way, second one is the way through which I'll be taking the addresses. Same question में लेके नहीं आया, but still I will solve the same question once again through addresses. I will solve. Don't worry about that. I will solve. Look at this. What is given? This is the list given. Integer list. What this particular sequence of code will print, that is the question. Understand. First, you don't try. I will explain. You just understand. Okay. Struct node star p. So we have created a pointer p of type node. Means that pointer p will be able to store the address of some node. Fine. P is equal to start link link. Start link and link means p pointer points to my third node. I guess इतना तो clear होगा. I guess this much is clear to everybody. Now, if this is done, let's go for the next one. This one. P arrow link. From right side, take the value of P ka link. Take the value of P ka link. This is P pointed by P node. It's link. What is the value stored here? What is the value stored here? The value stored here is the address of next node. So address of next node I will have to copy somewhere. Here, this particular node's address I'll have to copy. Where I'll have to copy? In the left side. Here, in the left side. Now, very simple trick I will provide you here. There is a simple trick which I have created by myself to explain my students these kind of things very easily. बहुत आसान सी एक ट्रिक है जो मैं आपको एक्सप्लेन करूंगा. रुकिएगा और समझिएगा. क्या है ट्रिक? If you have multiple arrows, look at this. If you have multiple arrows like this in the single statement, what you do? Rightmost last arrow and after the arrow whatever the field you have, keep outside. जो rightmost arrow है and after the arrow field you keep outside, remaining things you keep inside a bracket. Done. Rightmost arrow and the field. So rightmost last arrow and the field I have kept outside, remaining things inside the bracket. Now using the bracket, try to reach to a node. Try to reach to the node. Start first node, link second node. I have reached to the node this one. I have reached to the node this one through this inside the bracket. इस ब्रैकेट के अंदर जो भी कुछ लिखा हुआ है उसके थ्रू मैं एक नोड पे पहुंच गया. नाउ व्हाट आई विल हैव टू चेंज इज दिस नोड्स लिंक पार्ट. This node's link part you update by this node's address. Link part of this node you update by address of this node. Link part, the location, link part location means in the link part when we had last time address of this node, I'll have to update this. By what? Link part I'll have to update by address of this node. Let's take a pointer to this node now. हमने क्या किया? ब्रैकेट के थ्रू हम कहां पहुंच गए? ब्रैकेट के थ्रू हम पहुंच गए नोड पे. मैं वापस से रिपीट करता हूं पूरा चीज. राइट मोस्ट, हिंदी में बोलूंगा समझ में आएगा शायद ज्यादा अच्छे से. राइट मोस्ट एरो और उसका फील्ड बाहर रखा, बचा हुआ सब हमने ब्रैकेट में लिख दिया. ब्रैकेट के थ्रू आप पहुंचो नोड पे. स्टार्ट मतलब पहली नोड, उसका लिंक मतलब सेकेंड नोड. यहां पहुंच गए. अब इस नोड के लिंक पार्ट को आपको अपडेट करना है. लोकेशन ऑफ द लिंक पार्ट अपडेटेड नाउ बाय व्हाट? ये इस चीज से, ये हम पहले ही रेक्टिफाई कर चुके थे, पहले ही सॉल्व कर चुके थे. पी एरो लिंक मींस एड्रेस ऑफ दिस पर्टिकुलर नोड आई हैव टू कॉपी हियर. आई गेस दिस इज क्लियर, राइट? अभी आपको अगर नहीं समझ में आ रहा है ना, इट्स ओके. एक बार और एग्जांपल के थ्रू बताऊंगा. वंस मोर आई विल सॉल्व द सेम क्वेश्चन, सेम प्रॉब्लम, क्वेश्चन नंबर 1 itself यूजिंग वन एग्जांपल. यू विल अंडरस्टैंड इट इवन मोर दैट कहां अपडेशन हो रहा है, किस तरीके से. नाउ नेक्स्ट स्टेटमेंट सेज दैट आई विल हैव टू कॉपी द वैल्यू ऑफ पी. वैल्यू ऑफ पी, व्हाट इज पी holding? P is a pointer. Pointing to this node means P is holding the address of this node. If P is holding address of this particular node means I will have to copy somewhere address of this node itself. For this node's address, I'll have to copy somewhere. Where? Multiple arrows. Do one thing, rightmost arrow, rightmost link part, keep outside, remaining in the bracket. Remaining in the bracket. Now look at this. Look at this. P arrow link, reach to a node using the bracket. P, this node. Arrow link, this node. I have reached to this node. Yes. Now this node's link pointer I'll have to update. This node's link pointer I'll have to update. In the left side, I will have to reach to a location. I have reached to the location link part here. Update by the address of this node. Update by the address of this node means 9 ka next will become this. Now what is next? What is next is a long statement. Start a link and data. Again, I am doing the same thing. Rightmost arrow and the data part I will keep outside, remaining in the bracket for my understanding. Reach to the node using these, and that node's data I'll have to print. For 4 times link, yes. Start first node. Link, 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 and link. 4 times link, I have reached to 9. Its data part, 9 will be printed. 9 will be printed. बोलो समझ में आया कि नहीं आया? अगर समझ में आया है तो यस बोलो, नहीं समझ में आया तो एक बार और रुको. मैं सेम क्वेश्चन, आई विल सॉल्व द सेम क्वेश्चन वंस अगेन. I will solve the same question once again. Start, link 1 time, link 2 times, link 3 times, link 4 times, printed its data part. So this node's data 9 will be printed. One more time I will explain the same example using the pointers. एक को समझ में आया, बाकी सब सो रहे हैं. Okay, good. Let me revisit the same question once again with an example of addresses. मैं example of addresses के थ्रू वापस से same question को revisit करना चाहता हूँ, so that you can understand. 7519 7 5 1 9 then next values are 4 and 3. Don't worry, मैं पूरा क्वेश्चन वापस से चेंज करूंगा, वापस से क्वेश्चन सॉल्व करेंगे. Null. Let's take simple example. Let's say this particular node is stored in the memory on address 50. This node is stored on address 100. This node is stored on address 200. These are the red color. Whatever in the red color I am writing, these are the addresses of the node in the memory. Addresses, actual addresses. Okay. This is the address 300. Let's say this is address 350 and this is 400. I'm just assuming, ऐसा जरूरी नहीं है, it is not necessary that all the addresses should be in the increasing order. The addresses can be anything. Let's take simple thing. Now start. When start points to something, this first node, what exactly start holds? Start holds the address of the first node. So can you tell me what should be the value in the start? The value of start is 50, address of the first node, right? What should be the value here? What should be the value here? Address of the second node 100. What should be the value here? Address of the next node 200. What should be the value here? Address of the next node 300. Value here, address of the थोड़ा सा क्लीन कर देते हैं इसको. Address of the next node 350 and the last में address of the last node 400 and next one is null. Next node is null. Now look at this. Same question. I am copying from backside. this. Fine. Start का link is equal to p का link. Start link is equal to p का link. p link is equal to p. p link is equal to p. And one last statement, 4 times link and data. So it prints printf %d start 4 times link 1 2 3 4 and data. चलिए, अभी आपको सारी पिक्चर क्लियर हो जाएगी, सब क्लियर हो जाएगा इतनी आसानी से कि आप बोलोगे अरे सर ये तो कुछ भी नहीं था, दिस वॉज लाइक वॉकिंग ऑन द केक. ठीक है, इतना आसान हो जाएगा जैसे आइसक्रीम खाना आसान है आप लोगों के लिए, है ना. ओके, नाउ लिसन. Struct node start p. I have made a pointer, created a pointer of node type. It can store the address what? Of any node. Fine. Now I am assigning p. So variable p, pointer p will have this address. What address exactly? Start 50. 50 is link. What is there in the link part of 50? 100. And its link part. What is the link part? The link part of 100 is 200. If you remember, from right side I will have to assign the value. I am not copying a into b. I am not copying a here. I am not writing a here. What I am writing is I am writing the value of a. So value of a is 5. I am writing here in the left side. That the same thing I am doing. The value of link part 200 I will copy in p. So there will be a pointer p. That pointer p will hold the value 200. That means p pointer points to this particular node. I guess अब इतना समझ में आया होगा सबको. I guess that much is clear to everybody. Now let's go to the next statement. What it says, from right side take the value of p का link. P pointer pointing to this node which is 200, right? So P is 200, the value of link part of 200. Value of link part of 200 is 300. Value 300 I'll have to copy in the left side. So value 300, this gives me what? 300. 300 I will have to copy in the left side. What is the left side? Left side is start 50. Its link part, 50's link part is 100 and the node 100's link part. Now listen, I cannot write here is 200. तो लोकेशन कैसे मिलेगी? लोकेशन कैसे मिलेगी? How can I get the location? I'll have to stop now. The node 100 address node, this one, its link part I'll have to update. Its link part I will have to update whatever the previous value we had. This 100 ka link part you update by 300. 100 ka link part you update by 300. Make it 300 now. Make it 300 now. If you are making it 300, if you are making it 300 means now this link will be broken and 300 means address of this particular node will be pointed. This node is pointing actually to this node next. I guess this is clear now. अब समझ में आ जाएगा कैसे क्या करना है. Let's go for the next one. Value of p I'll have to copy in the left side. What is the value of p? 200. I'll have to copy 200 in the left side. Where? p 200. Its link part 200 का link part 300. 300 के link में 200 copy कर दो. Link of node with address 300, link of address 300, this one, link of address 300, this one updated by what? Updated by 200. updated by 200. Updated by 200 means this link will be broken and its next will be this node 200 wala. Now let's print start 50. 50 का link 100. 100 link 300. Look at this, 300. 300's link 200. 200 link 300 and 300's data. 300 data is 9. So it will print 9. बोलो अब तो समझ में आया कि नहीं? Now if you understood, then you will be the master of linked list. इससे आसान और कुछ नहीं हो पाएगा इस पर्टिकुलर क्वेश्चन का सॉल्यूशन. You will not get easier than this particular explanation ever for such kind of typical questions. So if you understood now, let's go for the next one. Second question now I guess you will be able to solve by yourself. This you will have to solve by yourself. This particular question you will have to solve by yourself. आपको ही solve करना है ये question. चल ट्राई करते हैं. ट्राई करते हैं. नेक्स्ट वन. लुक एट दिस. स्टार्ट लिंक. P is equal to start. It's link. P pointer pointing to the third node. No problem. Then P link. P link and its link. What is the value in this link? The value in this particular link here is the address of the next node. Which node? This node. So address of this particular node I'll have to copy somewhere. Where? In the left part. It says start ka link. Start link and its link part. So if you have multiple links, what you need to do is rightmost part out, remaining in the bracket. Start link. I have reached to this node. Yes. Link part of this node. I'll have to update. Link part of this node I'll have to update by what? Address of this particular node. So link part I'll have to update by the address of this node. Updated? Yes. Next. P value I'll have to copy somewhere. Where? Here. Large value, so many pointers. Yes, what should I do? Rightmost arrow, rightmost link outside, remaining thing in the bracket. Reach to the node with the bracket. P here, link, next node, link, this node. Now this particular node's link part. I'll have to update. Location here, link part I'll have to update. So if this link part was holding the address of next node, I'll have to update it by P. P means address of this node. I'll have to update it by P, address of this node. So this points to P. अभी देखिए, if this is the case, let's try to print the content. Rightmost arrow, rightmost data kept outside, remaining things in the bracket. Start link. 3 times link. Start link, and its data printed value 1. That is the final answer. So answer printed by this question is 1. मैक्सिमम लोगों को एक प्रॉब्लम आती है, वो ये इस क्वेश्चन में, जैसे कि मैंने यहां लिखा था, अभी राज ने पूछा एक क्वेश्चन कि सर यहां पे थर्ड स्टेटमेंट 100 का लिंक 200 क्यों नहीं लिया? अगर मैंने यहां 200 ले लिया होता तो मैं अपडेट किसको करेंगे बाबू? मैं अपडेट किसको करूंगा? मुझे उस लोकेशन तक जाना पड़ेगा ना, लिंक वाली लोकेशन पे. तो जो वैल्यू ऑलरेडी है उस वैल्यू से मुझे कोई मतलब नहीं है, मुझे उस लोकेशन पे अपडेशन करना है। वही तो एग्जैक्टली मैं समझाना चाह रहा था यहां पे कि अगर आप असाइनमेंट करते हो तो वैल्यू उठाते हो राइट साइड से जो असाइन करनी है। ए की वैल्यू 5 उठाई, आपने बी की जगह 10 क्यों नहीं लिया सर? सर यहां पे 10 क्यों असाइन नहीं किया? अरे यार ऑलरेडी 10 वैल्यू वहां पे है, मुझे तो बी की लोकेशन पे जाके और राइट साइड से जो वैल्यू आ रही है 5 उसको असाइन करना है, उसको असाइन करना है। क्या असाइन करना है? वैल्यू, वैल्यू असाइन करनी है जो राइट साइड में आ रही है। तो यहां पे जो डाउट आ रहा है आपका कि सर यहां पे 200 क्यों नहीं लिया, मुझे नहीं मतलब लेफ्ट साइड में वैल्यू लेने से, जो भी इस लिंक पार्ट की वैल्यू है रहने दो, मुझे उसको अपडेट करना है। 100 के लिंक में जो वैल्यू थी, चाहे वो 200 हो या 500 हो या 600 हो, मुझे उस लोकेशन पे जाके उस वैल्यू को अपडेट करना है जो राइट साइड से आ रहा है उससे। तो 300 आया राइट साइड से, मैं गया इसके लिंक पार्ट पे, 100 के लिंक पार्ट पे जो भी कुछ वैल्यू थी प्रीवियस वाली उसको हटाया और 300 लिख दिया। अब तो मुझे लगता है कोई डाउट नहीं आएगा तुमको, राइट? चलिए अब एक क्विज है, सिंपल सा, क्वेश्चन नंबर 1 फॉर द डे, ट्राई टू सॉल्व इट। आंसर दीजिए इसका, आपको हाफ अ मिनट मिलेगा इस क्वेश्चन का आंसर देने के लिए। विच ऑफ द फॉलोइंग इज एडवांटेज ऑफ लिंक लिस्ट ओवर एरे? इनमें से कौन सा स्टेटमेंट एक एडवांटेज है लिंक लिस्ट का एरे पे? Linked list has contiguous memory allocation. Do we have linked list with contiguous memory allocation? No. In the linked list, elements can be stored anywhere. Linked list is not having contiguous memory allocation. Linked list requires static allocation of memory for elements? No. ऐसा नहीं होता है, डायनामिक लगती है। कैसे, वो हम देखेंगे कल इंसर्शन के केस में। Linked list elements can be accessed randomly? No, you cannot access linked list randomly. If I say you will have to access fifth element of the linked list, you cannot reach to the fifth element directly, you will have to reach sequentially only. Last one, linked list has dynamic memory allocation. That's true, only D is correct. Answer is D. Next one, quiz number 2, another same type of question which you will have to solve. Same type of question. I will wait for your answer now. Once you are done, you will have to tell me what it prints. क्या print करेगा ये? What it prints? I will wait for your answer for 1 minute. And then you will give me the answer, what is the correct answer. Tell me, what is the correct answer? What is the correct answer? Oh, somebody says 4. Very quick, Gautam. Very quick. Let's see. Oh, now answer is changed. 9. Okay, let's see. Wait, somebody will solve definitely this question. I am waiting for your answer. A. Array, there is no any A here, there is no any D here, there is no any option at all here. A, B, C, D. We have 7, 5, 1, 9, 4, 3. Something among these will be printed or nothing will be printed. Let's see. Let's try to understand. P is equal to start link link link. Start link link link. Start 1 link, 2 link and 3 link. P pointer points to this node. Now next one, I'll have to update address of start, value of this start. What start holds? Address of the first node. Here, where? So I'll have to copy address of the first node somewhere. Where? Look at this. This is the part, link part. Which node's link part I'll have to update? Reach to the node, its link part you update by address of the start. P link link. P link and link. This node's link part I'll have to update. This node's link part means previous value whatever we had, that will be overwritten by the start. By the start. Now P link link link. From the right side value 3 times link. P link link, and this link means address of the first node. Address of the first node. Address of the first node. Address of the first node I'll have to copy somewhere. Where? Start ka link. Start ka link part. Start ka link part means this part will have the address of the first node itself, like this way. Now it will print start 1, 2, 3 and data. Start ka link same node, link same node, link same node, and its data part it will print 7. It will print 7. My class time is daily 7:30 PM Monday to Friday. We will be having classes regular in the sequence, one after another. Entire data structure I am going to cover first. Yes, Mansoori Afraz, yes, I know that yesterday's quiz questions are remaining. I forgot to bring those questions today. Definitely I will bring those questions tomorrow and we will solve those first. Answer of this particular question is 7. It will print 7. The linked list will turn into a circular list, and after that we will update the first node's link is same first node's address. So we will be having a self loop on the first node itself. Hence we will reach to only first node. We will lose the remaining